Here we've got two hockey players involved in a collision. The first player is 100 kilograms and he's moving at 12 meters per second in the northerly direction. And he will collide with a player that's 120 kilograms skating at 6 meters per second towards the west. They become tangled together, so they stick together as one big mass. The mass would be just 100 plus 120, so 220 kilogram mass. And we want to know how fast that lump of players will move after the collision. And they want us to use the trig method in this case. So first of all, we'll set up our conservation of momentum, which means my total momentum before has to equal my total momentum after. Now I have two players moving before, so two individual momentums, P1 plus P2. And after, it's just one big clump, so one big mass is moving after. So those two things are added, so I have to add them together tip to tail like we always do with vectors when we're doing the trig method. My resultant will be P final. So I've taken the liberty of solving for P1, getting a magnitude. So all I do is mass times velocity 100 times 12 meters per second, and I get 1200 kilogram meters per second, and we know it's north. Similarly for P2, player 2's initial momentum ends up being 720 meters per second west. Now I construct my diagram. So my diagram will look like this. Player 1, straight north, with a momentum P1 equal to 1200 kilogram meters per second. And then at the tip of that one, I start player 2, and we know it's towards the west. Now it's a little shorter. And player 2's momentum is 720 kilogram meters per second. Now that's supposed to be 90 degrees. I apologize for my lousy drawing there. So we've got a 90-degree angle in there because one's north and one's west. So we've got a right triangle. My overall answer, P final, will be from the start of this triangle towards the finish. So it'll look like this. From here to here. Like that. So there's P final that we're looking for. Now we need magnitude and direction. So we got to figure out the angle as well. So you can see we've got a right triangle. So all we got to use is Pythagoras. So the value of P final will just be the square root of 720 squared plus 1200 squared, which ends up being 1399.4. I'm not going to round too much too early. If we want to get a direction, I can use tan theta. Tan theta would be opposite, which is 720, over adjacent, which is 1200. And when I solve for theta, I just simply go tan inverse. And you end up getting 31 degrees, and that would be west of the north line. So we've got our value of the momentum, we've got our direction, all we need is the velocity. So remember, momentum is mass times velocity. It's one big mass, so this mass here will be our total mass. So our mass will be 100 kilograms plus 120, it's all clumped together, times V final, which is what we're looking for. All of that will equal 1399.4. Solve it for V final, and I get 6.36 meters per second. And we know the direction already at 31 degrees west of north.